Alright, welcome back. We go to the next one. So this nice and straightforward one, I think, comparatively, because we're starting with a quadratic. So the only thing we've got here that's different is the endpoints. So these endpoints bring into relief this idea of absolute and local. So we need to check these against whatever we find in the interval to decide which is the actual maximum, because whatever we find may be a max or a min. So let's go about doing that. So f dash of x will be equal to 2 will come out and multiply by 0.01, so that'll be 0.02x minus 1.1. So yeah, very straightforward as a derivative. What we want to do is set f dash of x to 0, which means we have to solve 4.02x minus 1.1 is equal to 0. So adding 1.1 to both sides, just the usual drudgery, which we now know as students that if we do that and be patient, we'll get there. Dividing by 0.02, how many times does 0.02 go into 1.1? So x is going to be in 1, there's 50 of those, isn't there? So 0.1, there's 5 more. So it's 55. So our x value, we will find an m equals 0 value at 55. So if we look at our interval, we can see that we've got a number in between these two. So the question still remains, when is that at a max? Okay. Alright, so if we consider this derivative, this M curve, the M curve can tell us a little bit about what's happening looking at the M curve or the interval. Now looking at the M curve is something that you've got to be a little bit careful about, but if you do it through the lens of an interval, this is something that I think you can manage quite well. So remember that this curve is actually so 55 is 0, and it's a linear, isn't it? So we don't even need to place it in terms of x and y. We just know that it's a linear, and we know that the M curve has a value of 0, an M curve value of 0 at 55. So if we check some value below 55, what we can see is that we expect 55 to be a local minimum. Okay. So we need to just check a couple of values below and above that. So can we check 50? Can we check 50? So 50, 20%, 2% of 50 is still going to be 2% of 50. So I better check that using my calculator. Is it going to be increasing or decreasing? Well, we know that it's decreasing because look at the positive nature of the line. So we know that this one is negative below, and we know that it's above. So we can say from this that it's the derivative, okay, f dash is our M curve, remember, f dash. We're saying the same thing, nothing new. F dash is less than 0, it's negative. Over here, f dash is positive. Okay, so that's good. because what that means is that all the m values are positive above 55 and negative below 55. So that's good. That's a change of sign. That's what we wanted. So that means that this point here is a local minimum. Okay, so this is increasing function. This is a decreasing part of the function. This is the M curve. So it's a little bit confusing, but you need to remember M curves are simply about M. What's happening with M at those values. All right, so the other thing we want to do is then think about, is that an absolute maximum? Okay, so we want to check our endpoints. So we have to do an evaluation of the function, not the M curve function, but we have to evaluate at f function 16 and f function 55. And that means that we have to look at this one, because that'll give us the values for comparison. Okay. By the by, what was the value at x equals 55? When we put 55 in, what did we get? So let's just check that. F55. Sorry, yep, 55. And I said 55 there, but that's meant to be 85. So we're checking 85 there. 55 is equal to 54 minus 1.1 times 55 plus 0.01 55 squared. So just nice to know the value, because we are looking at value comparisons, aren't we? So I'm going to put that into the calculator. So we've got 55 squared times 0.01, and I'll pop that into the memory. Then we've got 1.1 minus times 55, and I'll add that to the memory, and 54 we can add that to the memory. So all of that then should be the sum. So the memory would, great. Let's try that again. 55 squared times 0.01. That's hilarious, guys. Add that to the memory. 55. Actually, see, I did the wrong thing there because I made a mistake. So do it all again. 55 squared times 0.01. Now, oh dear, it's holding the previous value, so let's just get rid of them all. Clear it all. 55 squared times 0.01. Okay, so put that in the memory. 55 times 1.1 minus is equal to, so we'll add that into the memory, and 54 was the other thing, so we'll add that into the memory. All my sweeping away and clearing rate, I mean to press memory recall. So 23.75 is the value that we have when we're at that value, 75. So we need to check that against the endpoint values. So F16, we've got to do the whole thing again for F16 and for F85. So that'll be a bit of fun. I've had some practice now, so I should get it all correct, shouldn't I? So we'll go 16 squared times 0.01 and pop that in the memory. 16 times 1.1 minus equals, add that to the memory, and then what do we have? 54. Add that to the memory, so clear all that, and memory recall, and we get 38.96. 38.96. So that's higher than 23.75. Alright, let's do the 85. So we've got 85 squared times 0.01, and we'll pop that in a cleared memory. Then we've got 85 times 1.1 negative equals, put that in the memory, and 54. We'll add that to the memory. We'll clear all this other stuff away, and the memory recall for that is 32.75. Okay. Now, which number is bigger? Because we've also got F55, which was our minimum, and that is equal to whatever we set up there, 23.75. So if we look at all of these numbers, we can see that this one here is the smallest number, so it's the minimum. There's no smaller number at the values, but what we find is that the 16-year-olds have the maximum value. Okay, so the maximum value for the 16-year-olds. So when we look at find the average accident rate, find the age when the accident rate is a max and a min. So this is an American study because they're allowed to drive from 16. So the accident rate is at a maximum at age 16. Accident rate is at a minimum at age 55, which we worked out from calculus. Okay, so that's been able to give this one. Right. Very good. And we've got a curvy question, so we can have a look at that one as well. For the curve x cubed minus 2x squared, find the absolute maximum and the absolute minimum on the following intervals. So we'll be comparing, not unlike what we did before. So y dash needs to be set to 0, but before we can do that, we need to work out what y dash is. So differentiating 3x squared, 2 2's are 4, x minus 3, so we have a quadratic. I'll do my usual thing. You can use completing the square, or you can use the quadratic formula. Everybody seems to like to do their own thing. This product is minus 9x squared, so the roots of that can be 9 and 1 plus or minus, or it can be 3 and 3 plus or minus in some combination. So which I'm going to rebuild the subterm. So I'm going to use this grouping in pairs that I've used a few times because it's a bit easy with a non-monic, I feel, but that's only an opinion. So minus 4x, we're not going to get there with, is there anything else we can do? 3 and 3 might be 3. So is there anything else I can do for that one? 9 and 2. So minus 3 would be here. So really it's 3. We look at 3. It's just 3 and 1. So it's got to be 3 and 1. So we need to put in a 3. Where is it though? Minus 3 minus 1 will give us minus 4. Minus x, let's have a look at that. Let's take 3x out. That'll leave us with x minus 1. Now the idea here is that that repeats. And whatever we put out here should be the same thing. So that's not giving me what I want. So that's not it. I'm not going to do it that way. Yeah, sometimes you just got to experiment and try. If I use one of the formula methods, this is the problem with factorising. Isn't it? It's always the way. So, yeah, so that's all it is. It's just a case of running through it. And I think it could be because of the nature of the root. So I'm going to use the quadratic formula. So minus 4 plus or minus the square root of minus 4 squared. I think there'll be a root in this answer. Minus 4 times 1 times 3 times minus 3. So put that into brackets. Divided by 2 by 3. Okay, so we've got plus 4 plus or minus. Now 4 4s are 16. Minus times a minus is a plus. So 4 3s are 12. 36. Or 3 3s are 9. 4 9s are 36 either way. Over 6. So we get 4 plus or minus. Now that's 46, there you go, 52. So we've got the square root of 52, that's why the integers weren't coming out of the other one. So what have we got here? 52 halved is 25 to 26. So that can be expressed this way. 2 by 26. And the reason that we do that is because we can do 4 plus or minus root 2. 13. Sorry, it's 4. 4 by 13. Nearly. As soon as I saw that root 2, I realised. Yeah, we know. So 4 13s, 4 3s are 12. 4 3s are 12, carry the 1, 4 1 to 4, 52. Okay, so that's the square root of 4 times the square root of 13 over 6, so that's good. And that's now 4 plus or minus 2 root 13 over 6. We can now split the fraction. So we get 4 on 6 plus or minus 2 root 13 on 6. And clearly there's some factors here. So that's going to go into itself. There's a common 2 in here, isn't there? 2 will go into itself. So we'll get it in thirds. So it's 2/3 plus or minus root 13 on 3. So there are our two numbers where m is 0. M is 0 at 2/3 plus root 13 on 3. And it's also it's also a 0 at 2/3 minus. Now you can close the fraction if you want to. You don't have to leave the fraction out. Alright, so this equates to say something similar. 9 is 3, so it's more than 9, but it's less than 16, so it's about 3.5, 5.5, 5.5, 3, so it's about a 1.87 we'll go for. And for this one here, it's a similar thing, but it's minus, so that's a negative. That's negative, but it's about a half. All right, so at both those locations, you will find zeros. All right, so if we look at that M curve again, let's do the M curve, which is this thing. But remember, when we're looking at the M curve, we're treating it like the interval. It's a positive. It doesn't matter about any of that really. Those points represent the values for x1 and x2. So what did we say? The minus was negative a half. Okay, so this is the max. And we've got the plus down to a minus to a plus. So it's increasing. It's increasing to this one here, and then it's decreasing. So this is a max. It's decreasing to here, and then it increases. So this is a min. So there's some use in using this curve this way. Combining it with intervals is a nice, neat idea. So this one here's the minus, which is 2 minus root 3 on 13. I've joined the fractions up. And this one's 2 plus root 3, root 13 on 3. Got them back to front, didn't I? 3. Okay. All right, so we need to check those against these now. So we didn't do a value, did we? So if we put the x value in for those, so it's just a little bit of having to put our values in to our original function. And putting into our original function. So yes, it's a lot of work. Welcome to uni. Graduate class. Okay, so what I'm going to do, it's just a lot of work, so you've got to bear with it. And get approximately for the 0.5. So that's 0.875. And for this one here, minus 6.07. So there you min and your max. So it's unusual to work that out that way, but that's how it is. All right, now we've got to check that against these other guys. Okay, so we've got to put in the function at -1 and at 3. And do the same calculation again, all the way through. It is deliberately as you can. And it turns out that if you look at this thing here, these are actually unusual. Okay, so if we put that in, -1, that'll be -1. -1, minus times minus is a plus. -1 plus 1, but that's times 2. -1, and we put this minus in here, so let's just do one of them. Let's do -1 cubed minus 2 times -1 squared minus 3 times -1. You've got to go through all of them. So we're going to end up with -1 remains, that becomes a positive, but that's now a negative. Okay, now this becomes a positive, so that's -3, this is +3. Look at that, that's unusual. So what we found is a root. Okay, those endpoints are actually roots. They're solutions. Y has become 0 at -1. If we do the same thing at 3, 3 3s are 9 3s are 27, 3 3s are 9, 2 9s are 18, -9, minus, that's the same thing. That's 0. So we've got a very unusual situation in that our testing of intervals, that these are solutions, actual solutions, not just where's M, these are the actual X intercepts. Okay, so we worked out some interesting values, but either way, in comparison, when we compare the points A, B, C and D, the minimums and the maximums apply. Okay, so for the interval 1, 3, max at and min at. So the max is this one and the min is this one. They're the X values. That's your solution to A. So you've got to go through and repeat that all for B. The only thing we don't have to repeat are these. So for B we would do a similar thing, comparing for -2, now -3, 2, 3 plus 3, sorry. Now we know that 3 is an endpoint, which is 0. So that doesn't change from question to question. So that's still 0. So that +3 is still 0 because it was before. Now -2 we would have to check. Okay, so -2, if we put -2 into the function, we get 3. Now we're comparing 3 with our previous values, and what we find, remember these are the X values for our max min, not these guys. Okay, so what this means for this interval, the max at, min at. Now we've shifted because the maximum is not 0.8, it's 3. Okay, so -2 is giving us a +3, so that's got to be the maximum. I need to check that. 3 cubed -2 3 squared -3. So the minus stays here, so it's 3 3, so it's -27. That becomes a +9, but it's a -18. And 3 3s are 9, but it's a positive. So we get 27 minus 27 minus 18 is minus 37, 45, minus 45 plus 9, 36, negative 36. So the actual value, and why was I checking 3? Minus 2. Sorry about that. Minus 2. It'll come to us. Minus 2. Minus 2. And minus 2. So 2 2s are 4 2s are 8, but it stays. That squares to become 4, but it's minus 2 4s are 8. So that one there. And that's plus 6. That's minus 10. It's not 3, it's minus 10. But minus 10 is bigger than minus 6. So the minimum is at minus 2. X equals minus 2. But the maximum remains at this one. Okay, so you're checking your X, you're checking your absolutes. Okay, you're checking your absolute endpoints, and you're checking them, comparing them with what you found. So clearly the curve goes up at the endpoint interval in that particular case. And so we would have to sketch that and put that out. All right, so the next one is, I'll just do it here. The interval is minus 1, 4. So they're within the expected interval. So we can check it. Now, f minus 1, didn't we show before that that was 0? Okay. If we put our fx and our fx in, we got plus or minus x's, and we got 0.875 and minus 6.06. And then our final one here is the limit. That turns out to be 2. So if we compare all of those for max and mins, which is which? So this is our absolute minimum for that particular interval. However, this one is our absolute max. So just getting the values and comparing them, missing the trees for the forest, can be quite a challenge. All right, I'll leave that one there, and we'll come back and have a next one.